Hi guys, from last video we saw how if we call the coef test function along with the LM map with an LM object along with the new west function, we can generate a matrix that contain both the coefficient estimate along with the heteroscedasticity, autocorrelation, consistence, and error. In this video, we're going to use this HACSE standard error along with the coefficient estimate to do hypothesis testing and construct confidence interval. Just like it's quite similar to the one we do it in last assignment, except we're going to use the HACSE standard error. So we're going to coerce this evaluated expression as a data frame and name it as coef matrix, although it is a data frame. Yeah, but if we print it out, it's going to be you can see that like it's something like a matrix, but it is a data frame. So let's do a two-tailed test and on beta 1. As you can see, beta 1 is on the second row, and if we want to extract the beta for interest rate of Australia, it's going to be second row, first column, second row, first column, and this corresponding HAC as standard error is second row, second column, second row, second column, and then we want to test test it against the hypothesized value is equals to 1, so it's going to be -1. And if we run this read line, we can see that the test statistic is -3.73, and the corresponding p-value for using the t-distribution with the degree of freedom equals to 83, because like if you run the summary function on this LM object, you will see the degree of freedom is 83. You can see that the p-value is quite small, which is way smaller than 5%, so we can reject the null hypothesis at 5% significance level. In case we are from Dr. Brief's class, you're going to use the large sample assumption, and you can test it against the standard normal distribution, which will yield a result that are qualitatively the same. And for the second case, we're going to test to test the two-side test on the beta 2. So as you can see from the data frame above, the beta 2 is the third row. So to extract the coefficient estimate is going to be third row, first column, and HAC standard error is third row, second column. And the corresponding test statistic as the hypothesized value is -1, so it's -1. It's going to be a positive, and we can see that the corresponding test statistic is 3.9. If we generate the p-value of two tails, it's going to be again, it's going to be very small. Way smaller than 5%, so we can reject the null hypothesis at 5% significance level. And similarly, for if you rely on the large sample assumption, it's going to be we are going to test against the standard normal, and again, it is way smaller. It basically means like times 10 power of -5. So you can safely reject the null hypothesis. And so after doing two-tailed tests, we're going to construct a confidence interval. So if again, like for Dr. Yan's class, you're going to use the threshold from the t-distributions, and if you're in Dr. Brief's session, you're going to use the standard normal. So I'm going to use the t-distribution for demonstration in the following. We're going to construct the confidence interval for the beta 1. The left hand is basically we're going to use the coefficient estimate for beta 1 minus the threshold times the HAC standard error of beta 1 hat, and it's going to give us the left endpoint of the confidence interval. And similarly, we're going to plus the threshold times the HAC standard error of the beta 1, and stick it together. We're going to have the confidence interval for beta 1 construct used using the HAC standard error. And similarly for beta 2, we're going to use the beta hat, use beta 2 and also the coefficient of estimate of beta 2 as well as the HAC standard error. Yeah, so we just done the serial correlation part.